Hi, Dr. Sharhida. My name is Yamna Devi Annapurva Chandrasekharan and my metric number is 309594. I'm from Group 2, Hope Leaf. So today I'm going to explain about the core data structure behind our system. Let's begin with section 5.2 node structure and code implementation. So the concept is actually about each node is singly linked list contain two parts, data and link. Data is a child object which stores ID, name, age, pairwise level, and donation. The link is a reference to the next node. So as you can see the code mapping child node.java in this slide, info holds one complete child record. The link points to the next node and if link equals to null, this node is the last node. As shown in the report diagram, the last part, this directly presents the structure. This structure allows us to change child record dynamically. Now I'm going to talk about section 5.3 head node and linked list initialization. So the concept is actually about the linked list maintain a head pointer that always points to the first node. The code mapping, as you can see in the slide, the head equals to null means the list is completely empty. When the first child is added, the head will point to the next node. When the head node is deleted, the head updates to the next node. So this head is starting point for all operation add, search, update, delete, and now let's see how these concepts are used in search operation as well. So I will explain the process using flowchart from section 6.0 flowchart and algorithm.
So now let's visualize exactly what happens in our code when we add a new chat record. So it all starts in the head or node 1. So this adding a child traversal, the pointer will visits every node until the end of the node. So linked list needs to traverse from first node to each node until the end of the node, unlike the array where the programmers can access any element. So that's the difference between linked list and arrays. So we create a pointer called current here that acts like a cursor. So it starts at the head, which is node 1, and then asks a simple question: is my link pointing to anything? So first it sees node 1 links to node 2, so it moves forwards, right? And then it moves to node 2 and then checks again. Here at node 2, it finds that the link is actually null. So this tells the system to stop, that you have reached the end of the train. So this brings us to the crucial step. We don't create a new variable here. Instead, we perform an update operation. We take the existing link inside node 2, which was points to nothing, and then we update it to the point to our new record, which is node 3, soon to be new record, which is node 3, and just like that the chain is extended.
So now let me explain about the flowchart. So it start the user is in search tab. When and then second is the user enter input ID or name in the text field and click search. Third is the keyword empty. If yes, then show error. Please enter a name or ID to search. If it's no, then please continue. So fourth is first traverse linked list by ID, the right part. We always try ID search first because ID is unique. So start from head, moves node by node using current equals to current dot get link compares to equal is ignore case bracket. If ID found, immediately show one result in the table even if name also matches. N equals to n. But number five, if no ID match, then go to name search, which is the middle part. So again, start from head, traverse the entire list, collects all the matching names into an array list is in case of duplicate name. So six is if any match. If yes, shows all matches in J table. If no, then display no matching record found. And 7 is N. So this flowchart clearly shows linear traversal from head to node using link move to the next node, exactly applying the node structure and head concept as we saw 5.2 and 5.3. Now let's look at the actual implementation in child linked list in next slide. So now I would like to explain about child linked list. We have two search methods that perform linear traversal on singly linked list starting from the head. So first is search by ID. It finds a child by its unique ID. It begins traversal at head. Check each node's ID using equals ignore case bracket. If user can type C001 like small letter or big letter C001, both also work. As soon as a match is found, return the complete child record immediately. So if no match after full traversal, then means it have to returns null. Secondly, I'd like to explain about search by name. It finds all children with the same name. If some traversal patterns from head to end, it collects every matching name into an array list because names are not unique, also case insensitive. So returns the full list could be 0, 1, or maybe many child. These two methods demonstrate classic singly linked list linear search using node linking. Thank you.
Good day, doctor. I'm Lim Jia, matrix number 308123. Now I'll explain how the update tab works. And first, I will start with demonstration. Then I will explain the flow of update using flowchart. When a user wants to update a child record, the system first asks for a child ID or child name. If the user enters an ID, then the system will search for the first matching node. And if a name is entered, the system will collect all node with that name. And this part of search traversal already explained by my teammate, so I will not explain in details. Then after the search, the results are displayed in the table, which you can see just now, and the user can select the child they want to edit. The update happens in the linked list is actually through this method. And let me explain it line by line. First, child node current equals to head means that we start traversal from the head of the list by pointing current to the head node. While current is not null means that we keep moving node by node until the current is null means it already reached the end of the list. So next, we check if this node match the child ID input. So if a match is found, we replace the node's data with the updated child information. Then we stop the traversal because the update is already complete. So the above loop statement is for the match case. If not a match, then we will move to the next node. If we reach the end without finding the ID, then the update is considered failed. Next, I will explain how to delete a child. And first, I will start with demonstration first. Now, I will explain how the delete tab works using this flowchart. First, the user enters either a child ID or child name. If both fields are empty, the system shows an error message and stop. Next, the system search for matching child records. If an ID is entered, it's searched by ID. Otherwise, it's searched by name. Again, this part of search traversal has already explained by my teammate, so I will not go into details. Any match record are displayed in the table. If no match is found, the system informs the user and stop. If the match is found, show result in table. The user then select one child from the table to delete. Before deleting, the system shows a confirmation dialog to prevent accidental deletion. After confirmation, the systems perform linked list traversal to locate and delete the selected child safely. So the actual deletion in the linked list is using this method. Let me explain in details. First, check whether the list is empty. The head represents the first node in the list. If head is null, it means that the list is empty, so there's nothing to delete. The system immediately stops and returns false. Then we check whether the child to delete is the first node. Here, the system checks if the first node ID match the selected child ID. If it is matched, then we delete the head node by moving the head pointer to the next node. The all head is removed automatically, and this is the simplest deletion case and no traversal is needed. This step shows the traversal for deletion at middle or last. Now we handle deleting a middle or last node. Before, keep track of the previous node. Current points to the node we are checking. Traversal starts from the second node since the head case was already handled. Then we traverse the linked list. These loops move through the linked list one node at a time until the end and where the current equals to now. So we check for the matching child ID. For each node, the system will compare the stored child ID with the selected ID. If a match is found, then the deletions happen immediately. Then we delete the middle or last node. Here's the key idea. Instead of deleting the node directly, we change the link. The previous node skips the current nodes and points to the next node. This safely removes the node without breaking the list. So these logics work for both middle and last node. Then we move to the next node if no match. If the ID doesn't match, both pointers move forward and the traversal continue. So if the system reached the end of the list without finding the ID, the deletion is considered fails. Finally, once deletion is successful, the GUI table is refreshed to reflect the updated list. And now I'll pass to the next member.
Okay, so now I'm going to explain the visualization for display all. So this display all, the pointer will visit every node. So first we start at the head, of course, is node first, not one, and then copy the data. For example, Ali, age 10, and then it will add into our list for the GUI later, to show to the GUI later. And then moving from node 1 to node 2, the pointer visit node 2 and then copy the data. For example, we use Bala, and then after copy, the pointer will move to node 3, visit the node 3, and then copy the data. For example, the data is Kathy, and then copy the data, right? And then if the pointer hits null, the process will stop. So this ensures that no matter how long the list is, every single chat record will be retrieved and displayed on the screen.